Hannikainen, and I'm a software developer at Solita. And I'm today going to talk about Clojure, lenses, and traversals, and what they are and how they can be used. So I'm going to start off by talking a bit about what kind of problems nested immutable data causes. Primarily when you want to change something or you want to maybe read something in a bit weird way. Then I'm gonna go over quickly that what kind of solutions lenses actually provide here, how they can be combined, how you can write your own lenses, what traversals are, and how they fit into the picture. Then I'm going to go over the original example with the lens library, and if there's time, I might go over why do they actually work. So, starting off, we have a blob of data here, a list which contains maps, which contains some other data, and this time we would like to change the salary history for everyone who's in development. Specifically, we would like to increase the latest entry because for some reason someone put too low numbers in there. So we would first like to filter out only those who are developers, and then focus on those with last entry in the salary history, so skipping the ID number 2 here, and then increasing it by 10%. But the problem is that the data is nested within some lists and stuff, and we are using an immutable language, so we can't just go over the list and set things. But, well, let's try. This is a quick function I wrote that does it. Well, it's relatively simple Clojure. You map over the row, then pick out all of those who are developers and don't have an empty salary history, and then update the last element in the salary history. Well, there's nothing really wrong about this. If there's only like one or two places in your code base where you're doing this kind of data manipulation, then it's probably just fine. But if you're handling out some complex data transformations multiple times in different places at your code base, you might want to start thinking about using something that actually composes better than the standard Clojure functions here. But let's take a small step backwards. Lenses are essentially a way to view things and update things. And in our case, there are essentially guidelines on here's a blob of data. How can I get some part of this data out, or how can I update this data I'm currently looking at? And to do that, we need a couple of functions. These are from a library called lentes, which is a pretty nice library. I can recommend it. First, we are going to skip the actual function bodies here, but there are 3 functions here. The first is lens, which takes in a getter and a setter. The first function knows how to get some subpiece of the data out. For example, if you have a list, then it could be the function first, which returns the first element of the list, and setter, which is a function that knows how to update the thing, whatever the getter is looking at. For example, if you want to update the first element of the list, you would use update, then give the list, then 0, and the function you are updating it with. The second is view, which takes the lens and some data, and then returns the value whatever the lens is pointing to. And the third one is over, which takes the lens and the data and some function, and it uses the function to update the data at the point where the lens is pointing. So if we take the simplest lens possible, which is identity, which does nothing, here it's essentially just like calling identity on the data. It doesn't do anything, so it returns the list given as is. We are using some other lenses as well, FSD, which returns the first element, SND, which returns the second element, or focuses on the first and second elements, actually. So if we take the first lens and give it a list, then it will return the first element in the list, which is 1. And if we use the over function, which updates things, we give it the lens function and the data. It will focus on the first element and call the function on it and replace the element with that return value. So in this case, it will call increase on the 1, which returns 2. So the result is a list, or well, a vector containing 2. These can be combined using the function composition from Clojure core, which usually works from right to left with functions, but with the lenses, it actually works from left to right. So if you want to first take the first element in some list, and then the second element from that sublist, then you can just combine the two lenses with comp, and then pass it as a lens. And it will first, in this example, it will first focus on this pair here, and then finally this element here. You can use the same stuff when using over, so you can call increase on that same element using the very same lens, and it will update the value to 3. This is simple stuff. So at this point, we basically have a really complicated way to do updating. Wow. But well, let's take a closer look at how you can use this library to implement your own lenses before moving onwards. In this case, we have the identity lens, which, well, doesn't do anything. It's composes of 2 parts, which is the getter and the setter. In the identity lens, the getter part is the identity function from Clojure core, which returns the value what is passed in. This is the getter. If we would like to make a lens that focuses on the first element, we would use the first function. If we would like to focus on some key, for example, in a map, we would use the get function, or we could also use the keyword directly here. The second part is the setter, which looks kind of interesting, but essentially it just takes in a state and a function, and then it calls the function on the state. Because in the case of identity, when we want to replace the value with whatever the function returns, so we just want to call the function with the state. With some a bit more complicated cases, for example, first, we would pass in a lambda, which takes in the state as the first parameter, the function as the second parameter, and then calls update on the 0th element, which is the first element in the list. And then it will use the function to update the value to something else. That if you would use some keyword or some other key, you would just pass in the place of the 0. But well, all of these have been focusing on single things at the time. So we had lists, so we could take the first elements out or something like that. So if we want to look at multiple things at once, for example, we want to update all of the elements in a list, well, or we would like to return some key from a list of maps, then, well, IDE returns only single things, so we just can't use it with when we want to return multiple things at a time. So traversals are the key here. Unfortunately, we can't use the view function here because it just doesn't work with traversals, which instead of lenses point to multiple things at the time. But actually, since over what it does, it takes in a function and state and updates it somehow. Well, that sounds like it could take a traversal in which it actually can. And you can actually use lenses if you don't want to ever view things, but only change them. Then you can actually just use lenses and hope that no one is trying to read multiple things. So we take in a couple more functions. In this case, the traversal, which is the same as lens, but it's for multiple values at a time. To list of which is the same as view, but for multiple things at a time. And let's implement some traversal, for example. For example, here we have a traversal for all elements in some sequence. When we want to go over some things, we pass in the first function should return some sequence of things in case we want to go over all elements in a sequence. So identity returns the sequence as is. We could also use seek here or something, but I think identity is the clearest one here. The setter is a bit more complicated, but still pretty clear. We are still checking in the state and some function, and the standard Clojure core gives us a function called map, which goes over some list and returns a new list with the function called over all of the elements. And as I said, you can actually skip using this specific traversal function if you never want to use the lens for reading things. Well, how about some more complicated examples? If we would like to focus on the last thing, we could just take the last element out of the list and call it a lens. But since the element might not exist, it's actually a traversal, because if it doesn't exist, we don't want to return anything. But if there's one element, we would kind of like a list of that one element. In this case, we are returning a list. So when reading things with a traversal, the reading part is pretty simple. We are taking in a piece of data with this first function. This is the getter. So if the data is a non-empty sequence, then return the last element of that sequence in a list. Otherwise, return an empty list or a vector. Updating is also pretty clear. If the sequence isn't empty, call update on the last element of the sequence. Otherwise, return the sequence as is. And one more a bit more complex example here, filter, which takes in a predicate, and we would like it to focus on all elements which satisfy this predicate. Someone might actually know that this might violate some specific traversal laws, but we are not going to talk about them now. But let's just assume everything just works. So traversal, we have this wonderful function called filter from the Clojure core, which takes in the predicate and data and returns every element which will satisfy the predicate. Updating is a bit more messy, but it takes in the data and the function. So we thread the data, call the function on all of the elements which satisfy the predicate. So if we would have a list of 1, 2, 3, 4, and we would like to call it on all of the even members, we pass even as a predicate and some function. So it will here call the if we pass increase as the function in over, this would call increase on all of the elements in that list. And finally, since we don't want to change the data type, we throw it back into the container in which the data was in. Well, here we have some maybe 30-40 lines of code in total. Let's take a look at the original example now and whether these can be actually used there. So in the original example, we are mutating data, so we are going to use over, and then we are going to take all of the elements there which have the department as developer, focus on everyone who has the focus on the salary history vector, focus on the last element of the vector if it exists, and then just call the increase in function there, which in here raises it by 10% and then converts into an int, and then just pass in the data. Yeah, this function essentially does the same thing as the original function did, but by writing like 50 lines of code, we can reduce this example from 9 lines of code to 6 lines of code. The original function might be improved somehow, but since it's nested here rather than being sequential data, at least threading doesn't really work here. Some other method actually might. So here was actually a quick peek at the lenses in like 20 minutes or so. Are there questions so far?
Thanks for the presentation. There are no questions in the chat, but I can try to come up with something. Why wouldn't threading work with the original example?
Because the code is nested rather than being sequential. I can show it. I wonder what happens if I press this.
Everything explodes.
Yes. So is my idea showing?
Yes.
Yes. So here we have a bunch of code relating to the lens stuff here. So here's the function in the example. Here it's in unthreaded form. We can use this thing. We can thread it at least like this, but since the map function still needs to take in the function as an argument, and then this one has to call the conditional, at least I don't see a way to actually make this any clearer here.
Yeah, because you have to carry the whole thing there. I was just thinking something at first filter and then map and then chunk it to the somewhere, but yeah. But actually, yeah, I kind of liked the traversals abstraction. It looked quite effective, and I guess that it is very general, and you can use it pretty much anywhere.
Yeah, there are some people probably who in the audience who actually know better than me about them, but we actually had this kind of a problem in our code we are doing in our project we are currently developing. We had some data which was nested in a list, and then there was a map and then another list, and we would have to do some updating like this. So I ended up reaching out for a lens library at some point. But still, if you have this at like only one point, it's probably just better to write it like this, or probably in the unthreaded form.
Have you seen many lenses libraries used in Clojure world? At least personally, I haven't seen them used so much, but I've seen a couple of talks about them also earlier. So do you have any idea why they aren't so, or are they not so widespread within the Clojure community?
I don't think they are so widespread, pretty much, since Clojure actually has a pretty good standard library, especially things like update in and assoc in and so on. They work really well with the standard data types in Clojure. The things that they start to fail in are exactly when you have multiple things to do. For example, in this, you could actually easily focus on the first row here, and then, well, at least the first element here, by just using update in and then passing in 0 as the first key, and then salary history as the second key, and 0 as the third key. But I'm not sure if you can actually focus on the last element using updating that easily.
I guess what I have at least seen more is changing the original data to better suit the standard Clojure functions instead of creating new functions to suit arbitrary data. But but pick your poison.
Yes.
Okay, there's actually a new question in the chat. What are the differences between different lenses libraries?
Well, personally using the library I mentioned earlier, that is Lentes. There's Spectre is the another one that I've seen. It's a bit different since it actually uses Clojure spec rather than using standard functions. I'm not actually quite sure that's how it works, but if I would have to guess, I'd like to think that this is a bit more general, but Spectre would give earlier error messages, since it actually does checking with Clojure spec that the arguments are correct and so on.
Okay, there was also. Please go on.
I haven't really checked that how Spectre works. You're asking?
Yeah, the next question was exactly about Spectre. The question was that is this pattern used by the Spectre library, or is it different? but I think you already mentioned that you don't exactly know. But how do you see is the inspector like a pure lenses library, or is it something else?
I personally have a. I'm not exactly sure, but if I have understood correctly, and I haven't dropped off the meeting, have I?
I think you are here, but the image is frozen.
Okay, good. So, if I've understood it correctly, it's more like a safe way to access some keys in a map and doing that in a ergonomic way. While this example I've used it is more like having a powerful way of doing things, if not that safe. If we were using Haskell or something, we would have best of both worlds at the cost of some error messages.
Okay. There's a comment that Spectre solves very similar problems as lenses.
Yeah.
But there are not more questions there anymore.
Okay, Mikko, if you have some commentary about the subject, you can also open up the mic and start discussion now, since there are no other questions and comments.
Yeah, please, if you have something to say, open up or say hi or something.